Hi, welcome to our second video for Chapter 4. This is just a video on the prerequisite skills for Chapter 4 for trigonometry. So in this video, I'm just doing practice questions. These are very similar to the questions on page 220 in the textbook. So I actually suggest that you pause this video, go ahead and try to do all the prerequisite questions on page 220. And if you get stuck, you can then resort to this video. In this video, I'm just going to go through all these questions here. There are 13 of them. Okay, let's get this started. So classify each triangle by its side. So all these side lengths are equal. That's what these symbols are used for, to show they're equal side lengths. It's called an equilateral triangle. Equilateral triangle. Okay, the second one, B. So this, it looks like that might be 90 there, but it actually looks like it's a little bit too big. I think it's greater than 90. I'm just going to pay attention to the side lengths. We got 2, 3, and 4. Well, I know that's not a Pythagorean triple. So what I mean by that is 2 squared plus 3 squared is not equal to 4 squared. I know that's not true, so I know this can't be right angle. I actually know that 2 squared plus 3 squared is 4 plus 9, that's 13. So that means this hypotenuse would need to be a lot smaller than 4 for it to work out. So this has to be greater than 180. That means this is scalene, and we also call it obtuse because the angle right here is greater than 90. All right, this last one here, C, those are equal side lengths. We call this isosceles triangle. Sorry, let's spell this correctly. Isosceles triangle. Okay, question 2. For each triangle, create a labeled sketch and determine indicated unknown value. So in triangle ABC, angle A is 20, angle B is 50. What's the unknown angle? So let's go ahead, let's draw this. Angle A is only 20. And angle B is 50. We'll make this one angle B. That's 50. And we're looking for this unknown side length for C. We know that all interior angles add a 180. So it's angle A plus angle B plus angle C. So we got 180 equals 20 plus 50 plus angle C. That's 70. If I subtract it from both sides, I get 110 equal to angle C. So that's the missing angle. Okay, so that was part A. Part B, DEF is equilateral. Find the measure of all angles. So part B, we have an equilateral triangle. That means all the side lengths are equal, which means all the angles must be equal. So it's called DEF. We always use capital letters to label the vertices or the angles. We use lowercase to represent the side lengths. Okay, anyway, we're not looking for side lengths. They just want to know the angles. Well, all the angles need to be equal. So we have 3 of them, and we basically have 3 times some angle that has to equal 180. So that means that angle needs to be 60. So that's kind of obvious. Equilateral, there's always 60 degrees between all the vertices. Okay, and then part C. So we have triangle GHI. 2 sides are the same, and angle H is 50. Determine the measure of the other 2 angles. Okay, so let's go ahead and draw this. I can tell this is isosceles because 2 side lengths are the same. So we have GHI and put G up on the top. So HG is equal to GI. So these side lengths are the same. That's what we're told here. And angle H is equal to 50. That means this other one is also equal to 50 because they have equal side lengths. So remember, this angle of opening always corresponds to this side length. So the bigger this angle is, the larger the side length is. Well, if these have the same side lengths, then their angle of openings must be the same. So we have 100 there. That means there must be 80 left over, right? because they all need to add up to 180. Okay, we're also told that triangle JKL is also isosceles and angle L is 90. Find the measure of the other two angles. So this last one here, we have a nice right angle at angle L. And we're also told that it's isosceles, so these two sides need to be the same, and angle L is 90. So we could probably call this JKL, like that. What are the other two angles? Well, remember, if these are equal side lengths, opposite to them is their angles. So that just means these angles have to be equal. So they must both be 45. Angle J equals angle K, which is equal to 45 degrees. So this is a kind of a special right angle triangle. It's right angle because it's 90 degrees, but it's also isosceles because the side lengths are equal. All right, I'm just gonna compress all of this. Actually, I think I'm just gonna erase it. And we'll start the next question. Number 3. Use similar triangles to determine the unknown value in each figure. So we have a nice triangle here. We got another one here. They both have right angles here. And because this line crosses through this one, these have to have the same angles also as well. So I'm just going to draw that in. Sometimes I do a symbol like this. I show the angle and I put a circle around it, showing that they're equal. So if these two angles are the same, that means the third one also has to be the same, because remember they have to add up to 180. So I'll just call that 1x. Those are also equal. So these triangles must be similar because they have equal angles. So what is this side length x? Well, let's go ahead and let's try to figure this out. So this side is similar to this side in the triangle. This 5 is similar to this side, and their hypotenuse are also similar. So if this one is similar to this one, I can see that to go from here to here, I just have to multiply by 2. Right? So this triangle is actually twice the size of this one. So what's this side length? Well, it just needs to be this one times 2. Take the 5 and double it. Right? So I know that x must be 10. Because the triangle is twice the size as the other. Okay, we got another one right here. This one might be easier to see. So we have this big, large triangle, and then we have the smaller one. They're similar because they have equal angles. They both have 90. They both have this angle that's the same, and they both are going to have this angle that's the same because these lines are parallel. I know they're parallel because they both have 90 degrees here. So I then want to compare these side lengths. So this is 4, this whole thing is 8. Then we're told this is 3 here. And this is y. So what would y need to be? So the 3 is not from here to here. So yeah, this 3 is not all the way across. It's just this piece here. So this side is actually y plus 3. And this is just y. So because we know that we're multiplying by 2 to go from like this side to this side, we can see that that's like our scale factor or our proportionality factor. That means this side y, if I multiply it by 2, I get the other length, which is 3 plus y. So now I need to solve for y, so I can subtract y on both sides. That 2y minus y works out to just 1y. So we have y equals 3. Okay, which makes sense because if this is 3, this one is going to be twice as long, and there'll be 3 left over. Okay, question 4. Determine the measure of the unknown side in each triangle. So we're going to be using Pythagorean's theorem for this. Remember, this is just a squared. Maybe you probably learned it this way. A squared plus b squared equals c squared. Okay, where c is the hypotenuse. So in this first one, the hypotenuse is x, so it's x squared. That's equal to the sum of the other side squared. So this side squared is equal to this squared plus this squared. So 9 and 16 giving us 25. That's x squared. Well, what's x? We got to root both sides, so we get 5. Obviously, we're just taking our positive value when we square root. Also, you probably knew this was 5 right from the get-go if you remember some of the Pythagorean triples. So I call them Pythagorean triples because 3 squared plus 4 squared equals 5 squared. So this is called the 3, 4, 5 triangle. So it's one of the Pythagorean triples. So there's many of them, and you'll start to see some of them again. And when you see them, they're actually really quick to solve. So, okay, this one here. So we're given both side lengths. We're told this is y, and this is also y. So 6 squared has to equal y squared plus y squared. Pluck like terms, we have 2y squared. Divide both sides by 2. And we have 36 over 2 equal to y squared, which is just 18. Square root both sides, and we have y equal to root 18. We know how to simplify these radicals. So largest perfect square factor is 9. So I have root 9 times 2. And I can write this as 3 root 2. I'm keeping this as exact. Okay, next page. For each triangle, determine the primary trig ratios for angle A and angle C. The primary trig ratio. So I am going to need to use SOHCAHTOA for this. That's my acronym. It tells me what side lengths to use for each ratio. So for sine, cos, and tan. So they want to know all three. Determine the primary trig ratios for angle A and C. So they want to know sine A, cos A, and tan A. Well, sine A is opposite over hypotenuse. So for A, opposite is 16, and the hypotenuse is 20. So we have 16 over 20. I need to simplify this fraction. I can divide both of them by 4, and I would get 4 over 5. All right, I want to do the rest of them, but I actually need to know this side length. Okay, you might have noticed that earlier. So this is actually a good example of the 3, 4, 5. But let's go ahead and solve this one. So you could do it this way. You can write out Pythagorean's theorem, and you can say 20 squared equals 16 squared plus, this is called C because it's opposite to angle C, plus C squared. So we got 400 equals 256 plus C squared. So I got to subtract the 256, and this is going to work out to 400 minus 256 is going to be 144. So that means C is 12. So then we have 12 here for this side. I also noticed this is similar to the 3, 4, 5 triangle, that Pythagorean triple. It's basically the 3, 4, 5 triangle times 4. Okay. So what I could have did is I could have said, oh, this side must have been 3, and I'm multiplying everything by 4 to get 16 and 20. So I know that has to be 12. That's the other way you could do that one. All right, so now we know that that side is 12. We can write out cos A. It's adjacent over hypotenuse. It's going to be 12 over 20. Simplify that, divide both by 4, and we get 3 over 5. Notice it simplifies back down to the Pythagorean triple, the 3, 4, 5. Tan A, so that's opposite over adjacent. It's going to be opposite to A is 16, and the adjacent is the 12. So it'll be 16 over 12. Divide both by 4, and we get 4 over 3. When you do sine, and then you do cos right after, tan is real easy. Tan, you can actually just take this number and write it over this one. Notice that's what that is. You'll see that pattern after you do a bunch of them. Okay, I'm actually going to skip doing angle C. I'm just going to go ahead and start doing B, just because there's not much space. Okay, we're going to erase these. And we're going to call this one B. So we have 9 here, we have 40 here. We need the hypotenuse. So let's call our hypotenuse B, because it's opposite to angle B. So we can say B squared equals 40 squared plus the other side length squared, 9 squared. So 40 times 40 is 1600. 9 squared is 81. So we have B squared equals 1681. Okay. Now we're going to try to simplify this. So 1681, that's going to be a little bit tricky to try to simplify. So let's go ahead and we're going to write the square root of 1681. It actually works out to a clean 41. Okay. So we know that B must be 41. Okay. So now that we're given all those side lengths, let's write up the trig ratio. Sine is O over H. So sine of A is opposite, which is 9 over H, which is 41. And cos is going to be adjacent, which is the 40 over the 41. And tan, 9 over 40. Something I want to point out with this triangle too, the side lengths are always proportional to the angles. So whenever you have really tiny angles, you have small side lengths. Largest angle is 90, has the biggest side opposite to it, 41. So it's always going to go that way. The bigger the angle, the bigger the side length is opposite to it. Okay, number 6, use a calculator to find the value for the 3 primary trig ratios for the given angles. So let's go ahead and do that. Sine of 90, which is just 1. We'll see why that is, actually. So sine of 180, also a special 1. We get 0. And then sine of 135, it is 0.707. Okay. All I did was sine for these. So I just did all the sine ratios. Cos, we would do the same thing on a calculator. Just look up cos. Cos of 90 is 0. And then cos of 180 is actually negative 1. And cos of 135, negative 0.707. Okay. And then we can do the tan the same way, just using the tan button up here. Okay, I'm sure no one will have a problem with those. If you're not sure how to use your calculator, just let me know and we'll figure it out. Okay, now it says find each angle of measure to the nearest degree. So cos A equals 0.83. Well, if cos A equals 0.8314, I need to find angle A. So what I need to do is the cos inverse, right? So right now it's cos of A. I need to do the cos inverse to get A by itself. So it's going to be cos inverse of 0.8314. Again, always make sure you're in degrees, which I am. So we're going to have cos inverse 0.8314. 33.75. It says nearest degree, so 34 degrees is what we'd have to round to. Okay, so that was A. We'll do B right here. sine of b equals 2 over 3. So to get b, we're going to have to do sine inverse of both sides. So sine inverse of sine b cancels out the sine, and you're left with just b. So sine inverse of 2 over 3, let's put that on our calculator. 41.8, we round up to 42. Okay, you can write that as b, or you can write angle b. Both are okay. And the last one here, we got root 3. So tan c equals the square root of 3. So c is going to be tan inverse. So remember, whenever you do tan inverse of the right side, you're actually finding the angle. Okay. When you do tan of the angle, you're getting the ratio. If you do tan inverse of the ratio, you get the angle. So let's try tan inverse here, and square root of 3, 60. Okay, we are cruising. Let's look at number 8. I'm just going to delete these. This is triangle ABC. Angle B is 90, angle A is 60, and B is 12. So we have angle B. We can draw that first. B is 90. We have angle A is 60. So I could do that like this. And I'll make that next bigger one 60. That's angle A. And here we'll have to be C. It says side B is 12. Well, that's always going to be opposite to the angle. So this is 12. It says cuts a triangle and mark all given measurements. So that's what we got for A. Part B, determine the length of side AB. So now we're looking for this side. Well, this is adjacent to 60. So I can actually write an A here for adjacent. So if I'm given adjacent and hypotenuse, what do I want to use? Well, if you remember, oops, sorry, try that again. SOHCAHTOA. So which one uses adjacent and hypotenuse? Well, that's cos. So I can do cos of 60. That has to be the ratio. That's going to equal the ratio of this side to this side. So it's going to be equal to x over 12. So let's find x. Well, let's multiply both sides by 12. Remember, don't multiply the 60 by 12. You have to multiply cos of 60 by 12. So I like to write that 12 in front. And you can put it in that way in your calculator. So 12 cos of 60. And we got 6. It says determine the measure of angle C. Well, that's okay. Angle C, it's going to have to equal 180 minus angle A minus angle B. Because all of them have to add up to 180. So we got 180 minus 60 minus 90. So that works out to 150. So 180 minus 150 means there's 30 left over. Okay, this is actually a special triangle. When we have 30 and 60, it actually creates a special triangle, which we'll learn about in 4.1. So that's my final answer for part C. Okay, question 9. To build a secure roof truss, a structure that supports a roof, the angle that the truss makes with the horizontal should be no more than 45 degrees. Richard is an architect who just completed the plans for a new house so that the roof trusses he has designed for the house will be secure. So they need to know that these are no more than 45. Okay, so looking at this one up here, I can see the total height of this is 12. I can see the total length is 28. So that means one of these sides is 14 and the height is 12. So we actually just have this for that one triangle. We have 12 and we have 14. And we need to know what this angle is. It needs to be less than 45. So how can we check? Well, let's call it theta. Okay, just a Greek symbol for the angle. So what trig ratio could relate the opposite side to the adjacent side? Well, that's just tan. So tan of theta is going to equal opposite over adjacent. So tan of theta would be equal to 12 over 14. This means tan of theta is equal to dividing both sides by 2, we get 6 over 7. Well, what's theta? Well, we'll have to do tan inverse. So tan theta is going to equal tan inverse of 6 over 7. So I hit the tan inverse button. You might have to do second tan for this to get tan inverse. 6 over 7. And it works out to 40.6 degrees. Okay, that's good. It just has to be less than 45 or no more than 45. So that one, this side is actually fine. Let's check out truss 2. Truss 2 actually looks even safer. So this one here. So I'm given the side length 6 and 10. That means this angle here is 40, or not, we want to check this angle. So let's call that theta. So I'm given the opposite. I'm also given the adjacent. So that's going to be tan again. So tan theta equals opposite over adjacent. So tan theta equals 6 over 10. I should simplify this. So we'll write, divide both sides by 2, and we'll get 3 over 5. So that means theta is going to equal tan inverse of 3 over 5. Make sure you do the tan to the negative 1, or tan inverse 3 over 5. 31 degrees. So that one's also safe. Okay, now for the last few questions. So if you remember these things, you're actually doing great, because I know your grade 10 course was a while ago. So this next part says apply the sine law and cosine law. So we need to write those out first. So let's start with cosine law. So we'll write this out in blue. So the cosine law is, we can write it this way. We'll say c squared equals a squared plus b squared minus 2 times a times times b times cos of the angle in between, which would be angle C. Now, why do we use sine law, cosine law? So first off, we always use it when we have non-right angle triangles. Okay, it's only for non-right angle triangles. So I'm going to add that in. Non-right angle. Okay, if we have right angle triangles, we just seen that we use SOHCAHTOA to solve these. We do all our trig ratios. It's really easy. This juicy formula here, okay, only use it when you need to, which is going to be when we have non-right angle triangles. So the way how I remember this, I'm just going to draw out the triangle. It would look for something like this. And I'll call this A, this is B, and this is C. So that means opposite to them, we have little a, little b, and little c. So if I wanted to know side length C, this one here, I would need to know B, I would need to know A, and I would need to know angle C. Okay, because in order to calculate it, I have to do A squared plus B squared. And notice we have A and B again, and we have cos angle C. So I need those three pieces of information. I need A, I need B, and I need the angle in between. They call this side angle side. When you have two sides and the angles in between, that's when you should use cosine law. So if you're looking for the side that's opposite to the given angle. So we'll talk more about these a little bit later, but basically this is the cosine law. This could be rearranged. If you wanted to figure out A, you could bring all these things over to the other side and then square root everything. And it is a little bit messy, but it's doable. So anyway, that is the cosine law. We'll see an example of it soon. And then we have the sine law. Okay, I'll do this one in red. So this is also for non-right angled triangles. And basically the sine law states it can be written two different ways. We can say sine of angle A over the side length A is equal to sine of angle B over its opposite length B, which is also equal to sine of angle C over its side length C. So these are always pairs, okay? The angle and the side length. You can see here, they're always a pair. So these ratios are always true, no matter what. So we can use them. If we have two sides and one angle, maybe we could use these two to find one of the missing sides or something. So this equation can also be written the other way. So I'll write or here. You could also write it this way. Little a over sine angle A equals little b over sine angle B equals little c over sine angle C. So how do I know which one I'm going to use? Well, I always write my unknown first. So if I'm looking for a side length, I'm going to write it out this way. And I'm going to write the sides on the top. If I'm looking for an angle, then I'm going to use these ones on the left. I'll probably grab the two that I know, and that way I can isolate for the angle, and the angle is already in the numerator.